Picture this, you're sitting in the exam hall. The invigilator says, "You may begin," and instantly you hear the furious scratching of hundreds of pens. The clock starts ticking, it's literally a Formula One race, and every single second counts. Welcome to today's Explainer. I'm your host, your chief strategist, and today we are opening up the examiner's playbook for Cambridge Computer Science. Whether you're running the track for syllabus 0417, 0478, 0983, 0984, 2210, or especially the heavy-hitting AS and A-level 9618, we are talking about high-performance exam strategy today. We're zooming in on one specific, highly challenging area from the recent source reports, constructing truth tables from problem statements. We're going to apply literal pit crew strategies to your exam timing to ensure you don't stall out when the pressure is on. So strap in, because we're about to decode exactly what the examiners want. Let's start by validating your struggles, because frankly, this topic is where a lot of candidates crash out. The principal examiner reports explicitly state that this is one of the most notoriously difficult and misunderstood areas of the entire syllabus. To understand why, I want to introduce you to two typical students. Let's call them Alex and Sam. Now, Alex is a hard worker, but Alex overloads every answer with raw computer science facts, spelling 1,000 words onto the page with zero actual analysis. Total engine flood. On the other hand, we have Sam. Sam treats the exam like a sprint, rushes through the reading, entirely misses the command word requirements, and just guesses the final binary outputs. When we look at their past paper answers side by side, it is just a sea of red pen marks. The translation from written English into pure logical mathematics is inherently tricky. But today, we are going to fix those red marks for good. Here is our race plan for today. We're breaking down the examiner's playbook into 5 critical sectors. First, the truth table challenge, where we'll diagnose the real problem. Second, theoretical foundations, looking at how to build your engine. Third, our step-by-step methodology, which is your pit crew procedure. Fourth, top examiner warnings, identifying the sharp corners on the track. And finally, critical analysis and evaluation, the final straight to securing top marks. Let's dive straight into Sector 1, the Truth Table Challenge. Now, the crucial point here is understanding exactly what the exam is trying to test. It is not just about getting the final ones and zeros. Think of a real past paper question, say, an automated greenhouse that monitors temperature and humidity to trigger an alarm. When Alex looks at this, he writes a massive paragraph about how greenhouses work. 0 marks. When Sam looks at it, he just slaps down a table of alternating ones and zeros, completely ignoring the specific conditions of the problem. Also 0 marks. So what is the missing link? The missing link is this critical concept from the reports, the method mark strategy. You have to realize that Cambridge examiners are actively looking to reward your process. This is your pit crew precision. Your methodology is just as important, if not more so, than your final output. If you just guess the final truth table values correctly without showing the logic gates or the intermediate expressions you derive from the problem statement, you are leaving massive points on the table. The examiners want to see the gears turning in your head. Okay, before we continue to unpack this, I need you to do something. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now so you don't miss any of our strategy guide. Moving right along into Sector 2. Theoretical and logical foundations. Understanding the theory behind the logic is what gives you the confidence to tackle any bizarre scenario they throw at you. This is where we introduce the ultimate toolkit for structuring your computer science answers, especially when you have to explain your logic. We call it the PEAL framework. That stands for point, evidence, explanation, and link. Top students don't just write, they architect their answers. When a command word says, "Explain how you derived this truth table," you make your point, you provide evidence from the problem statement, you explain the logic gate used, and you link it back to the final output. The source reports reveal a really stark contrast here. The assessment framework heavily prioritizes analytical depth over a superficial breadth of memorized facts. Remember Alex? Alex relies on superficial breadth, just memory dumping everything about and, or, and not gates. But analytical depth means using PEAL to systematically tear down the specific problem in front of you. Now, let's do a quick interactive challenge. I'm going to put an invisible 30-second timer on the clock right now. Think about Alex's brain dump versus an answer that clearly states, the alarm sounds, point, because the temperature is above 30 degrees, evidence, meaning both inputs must be true, requiring an AND gate, explanation, which results in a 1 in our final output column, link. Time's up. You can easily spot which one has analytical depth, right? It's the PEAL answer every single time.
These are the core assessment principles the examiners are desperately looking for: precise definitions, causal relationships, evidence-based reasoning, and integration. But pay super close attention to that last point. The principal examiner reports specifically highlight that candidates who reference cross-topic connections achieve significantly higher scores. This means if you can integrate your truth table logic with other syllabus areas, like relating it to data structures, hardware architecture, or specific programming constructs, you are essentially putting a turbocharger in your exam engine. Examiners absolutely love it.
All right, Act 3, the transformation. We're getting into Section 3, the step-by-step methodology. How do we actually do this in practice? It's time to take those red pen marks on Alex and Sam's papers and transform them into green check marks. We need a blueprint. So, how do we systematically tackle these complex examination questions without panicking and rushing like Sam? When you are staring down a massive past paper problem under intense time pressure and that clock is ticking down, you absolutely need a reliable procedural framework to fall back on. You don't have time to invent a strategy on the fly. The very first step is command word decoding. If the command word is draw, you do one thing. If it's evaluate, you do something entirely different. Let's look at the exact 5-step procedure that top-tier candidates use. The analysis of top-scoring answers points to this exact algorithmic framework. Let's do a 60-second mental rewrite for Alex and Sam. First, deconstruct the question. Underline the conditions. Second, extract relevant data. What are our inputs and outputs? Third, select your analytical framework, which means mapping out the logic gates. Fourth, execute your solution using absolutely clear, unambiguous notation. No messy scribbles. And fifth, present your final answer using correct terminology. If Sam had just followed these 5 steps instead of rushing to the finish line, he would have picked up every single method mark available. This isn't just a suggestion, this is your core racing line for the exam. So you remember this 5-step procedure under exam pressure? The source material suggests a really fantastic memory hack. Use a visual story method. Encode these concepts by creating a mental narrative. Picture yourself as a mechanic. You physically deconstruct a broken engine, you extract the glowing data parts, you select your tools, you execute the repair, and present the finished car. Visual sequencing locks the steps into your brain. Okay, listen up, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Welcome back. Let's shift gears into Act 4, which is an interactive workshop based on Section 4, Top Examiner Warnings. Pay extremely close attention here, because these are the specific pitfalls that are costing students entire grade boundaries. We're going to do some rapid-fire challenges to test your instincts. Challenge 1 is a data scan. Imagine a complex computer science truth table on your screen right now. I'm putting 60 seconds on the clock. Go. You have to scan the inputs, look at the intermediate columns. Can you spot the core trend? The outputs only switch to 1 when both inputs A and B are identical. 10 seconds left. End time. If you recognize that as an XNOR logic pattern, you just aced the data scan. Now for Challenge 2, find the flaw. The principal examiner reports explicitly reveal these top 3 mistakes. Number 1, candidates confuse cause and effect. They mix up the input condition with the resulting output action. Number 2, forgetting boundary conditions and edge cases. Number 3, generic answers lacking context. So let's look at a flawed sample paragraph. The alarm goes off, so the temperature must be high. The inputs are 1 and 0. Find the flaw. You have 30 seconds. Look closely. The flaw is mistake number 1. The student confused cause and effect. The temperature being high is the cause. The alarm going off is the effect. Reversing them loses you all your method marks. Let's talk a bit more about that second mistake. To pull yourself into the highest marking bands, you must bridge the gap between a common mistake and a top candidate action. A common mistake is ignoring boundary conditions. This is like a race car driver ignoring the track limits. Don't just build the truth table for the obvious everyday inputs. You must rigorously test your algorithmic thinking against edge cases. Ask yourself, what happens when all inputs are true simultaneously? What happens when they are all completely false? Does your system crash, or does it output a logical 0? Time for Challenge 3, speed writing. The reports are incredibly explicit about this examiner alert. Candidates consistently confuse key terminology. They use and when they mean or they mix up NAND and NOR. So, your challenge. I'm putting 30 seconds on the clock. Write one perfect PL paragraph defining your variables before you construct the table. Go. You need to explicitly state, let variable T represent temperature, let variable H represent humidity. Time's up. This incredibly simple step, defining your terms clearly before deploying them, proves to the examiner that you have the theoretical foundation locked down, insulating you from losing those precious marks.
All right, we are entering the final sector. Act 5, the final system and critical analysis. Let's conclude by examining the evaluator's mindset. We are looking at what truly separates a standard passing grade from a phenomenally exceptional one. This is about building a foolproof system.
Top-tier problem solving uses this specific deconstruct, solve, evaluate cycle. First, identify the given info. Second, break it into logical steps. Third, solve it systematically. But listen to me, the evaluation process does not end there. Step 4, checking for reasonableness, is absolutely critical. Look at your completed truth table. Does the output actually make logical sense in the real-world scenario given? And step 5, making justified recommendations to ensure every single conclusion is evidence-based. These last two steps are exactly where students like Alex and Sam drop off, leaving the top marks for you to claim. To hit the absolute highest academic benchmarks, your answers must demonstrate true evaluative thinking markers. The reports show you need to analyze trade-offs, acknowledge limitations, and justify decisions with hard evidence. This brings us to the 3 rules that guarantee top marks. Number 1, command word decoding. Number 2, strict PL framework application. And number 3, the time management matrix. Now listen closely. Students who implement these computer science strategies see an average improvement of 2 full grade boundaries, but that only happens if they practice consistently with our weekly videos.
This matrix summarizes our entire Pit Crew strategy today. It shows how the practical application of truth tables develops your broader programming skills. When you design, you create algorithms. When you implement, you build solutions with clear notation. And when you evaluate, you test thoroughly for validated performance. Mastering this isn't just an isolated skill. It's the foundation of your entire computer science capability. So here's your final reminder. Subscribe to our YouTube channel Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
I want to leave you with this final provocative thought. As you prepare for your next paper, look at your study methods. Are you prioritizing analytical depth over superficial breadth? Are you building the logical, evidence-based mindset that these examiners are practically begging for? Stop just memorizing and start analyzing. Now it's your turn. Drop a comment below with your target grade for computer science and the biggest challenge you're currently facing. Our team reads and responds to every single comment. Make sure to like and share this video with a study partner who needs a wake-up call. Ace the exams. Your Cambridge success starts here. Keep building those essential analytical skills, and I will see you on the podium.